the extent of that polygon. This is a new utility which has been incorporated into most of the GIS software like ArcGIS and all. So this particular bounding box concept is also being used to fast retrieval of the polygons. So that is also there. So but you can use this particular function for the measurement operation. Now in all these measurement operations, we have seen that we are just simply retrieving the data, but we are not playing with the data, we are not changing the data. So we are just simply seeing the original data. So we are not changing the original data values. So there are various ways of doing a spatial selection wherein like queries. I think you might be aware about different queries covered in the non-spatial data model. Especially if you see the queries in the SQL, you can fire different type of queries like select statement, select star from this, where this is equal to this. So you can apply these queries to a map wherein you are simply retrieving the data, whatever is available. You are not changing, or you are not updating, or you are not doing any operation on it. You are simply retrieving the data. So they are all part of spatial selection queries. Now you can there are different ways of getting the data from the vector data model. One is interactive. Interactive will come to that part. You can simply click a polygon and you can get all the details of that polygon by highlighting the attribute table. Or you can even vice versa. You can highlight the table, the record of a table, and then the polygon will be highlighted. So it's an interactive way of selection. So and then the second is the spatial selection by attribute condition, wherein you apply certain condition to like you have some 1,000 records or millions or lakhs of records are there. So you can select a particular record on the basis of condition, like where clause you can use. So and you can identify a particular polygon. So that is also a spatial selection where I am not changing the original values, but simply I am retrieving whatever the available data is present. So you have different type of spatial selection by attribute conditions, by using relational operators, by using logical operators, and you can even combine these attribute conditions like two operate like logical as well as relational. So you can combine this spatial selection and generate and get some results. Then spatial selection using topological relation. Now this is a very good utility which has been incorporated in ArcGIS, and also if you see in Quantum GIS there is only one spatial selection relationship included, that is intersect. So that is only you can use. I'll show you how you can use this spatial selection. Now this topological spatial selection will see earlier what we used to do is whenever we want to retrieve some polygon, you have to do certain set of operations. But here basically you use these topological relationships, you identify certain record, and then you can do the further analysis or further selection on the basis of topological relationships. So there are some around 8 to 9 relationships which you can use for spatial selection. Now here you are using, you can use not only you can have two types of two data sets. You can apply a topological relationship and you can generate the records. So selecting features that are inside selected objects. So inside is one of the topological relationships. Selecting features that intersect. So you can have the two different feature class or vectors. You can intersect them and you can get the information that is the common area, and then selecting features adjacent to selection objects, and then selecting features based on their distance. So you can apply different type of topological relationships in order to retrieve the data. Now here also I am emphasizing that we are only doing a spatial selection, but we are not changing the original data values. So if you see interactive, you can see that you can select a particular now there are two selections. One here I am selecting a record, the moment I select this record, this polygon will be selected. So you can select any of the record, automatically the polygon will be selected. So this is a interactive way of selection, like this. And then the other way is, if you do a selection over here, automatically the records available in the table, they will also be selected. So that is one of the way of interactive selection. Now in attribute condition, we define a selection condition on the features attribute in a query language such as SQL. So you can use a SQL statement wherein you can retrieve any record, or you can retrieve any polygon on the basis of certain attribute condition. Now you display the result both on the map and in the attribute table. So answer questions, where are the features with? So how I can answer this? I have certain set of relational operators which I can use for selecting a particular polygon. Now suppose there are certain relational operators like less than, equals, less than or equal to, or greater than equal to, or does not equal. So you can apply these all relational operators to a condition in the field. Now field, or you can also call it a column, you can apply a condition to a column by making use of select statement. So you like area less than 400,000. So I can easily apply this condition. So automatically those polygons or those records will be selected which satisfy the condition. So you can see that these polygons automatically get selected. If I apply this thing like select star from the feature class or the shapefile where area size is less than 400,000. So this is the very simplest way of selecting. So you don't have to select one by one. Apply a condition, apply a where condition, and you can automatically get all those data. Now there are certain logical operators which are being used in selection by attribute condition, like AND operator, or not operator. Now if you see AND operator, it is simply based on Boolean logic. Like if you recall your like truth table, where you can have, if you talk about a AND operator, this is like something like 0 0 0. Like in A you have 0, B 0, then your result output will be 0. Then if A is 1, B is 0, then output also will be 0. If A is 0, B is 1, then also output will be 0. But if A is 1 and B is 1, and then your output will be 1. So you can use the same truth table concept in this and generate the outputs. So